Okay. Good morning to all of you. I welcome all of you for this digital tonic session. Okay. So before getting into today's topic, as usual, we will see what are the things we have discussed in the previous session. Okay. So in the previous session, we have discussed binary adder. Okay. What is the purpose of this binary adder circuit? Can you type it in the chat? Which operation you can perform using this binary adder circuit? Kindly type it in the chat. The students kindly interact more in the class. Okay. See, just to phone a session and a path of the question. So binary adder is a circuit they are using for what? Half adder and full adder operation. Okay. See, half adder and the full adder are the basic building block of a binary adder. Okay. So binary adder generally use for performing arithmetic operation. Enna arithmetic operation? Okay, very good. Addition operation. Okay, for example, if I want to design an 8-bit binary adder. Okay, 8-bit binary adder na design pannona, how many full adders I am in need? To design an 8-bit binary adder, how many? Yes, Srihari, very good. 8 full adders, or else what we can go for? Instead of 8 full adders, what we can go for? 1 half adder and 7 full adder. Okay, very good, Srihari. Very good. Okay. So we have designed a 4-bit binary adder circuit in the previous session. Whether we used the usual KMF method or some other approach we have followed. What approach we have followed? Repeatedly, we have used the same block again and again. What we told that? Kindly type it in the chat. Block design. Yes, modular design approach. Very good. Okay. Then we have discussed about binary subtractor. Whether we have used the full subtractor to design binary subtractor. How we design binary subtractor? Whether we used the full subtractor? See, in the case of binary adder, you told we have used the full adder circuit. What about binary subtractor? Binary subtractor la nama full subtractor use pannamapa? No, we have used full adder only. Srihari, very good. Okay. Then how we perform subtraction? How subtraction can be done with the help of adder circuit itself? Yes, very good, Srihari. Very good. Sabarisheti, you have replied XOR and full adder. Very good. Okay, that we have used for designing adder cum subtractor circuit. Okay, very good, Srihari. So design of 4-bit binary subtractor circuit we have discussed. Then binary adder cum subtractor. Okay. So in that we have one more control input. What we set that control input? In the case of binary adder subtractor circuit, yes, very good. M, what we call? It is select line. Okay, to select the mode of operation. Adder na M equal to 0 sonno, subtractor na enna sonno? M equal to 1. Very good. Okay, so now we will move on today's session. Fine. So here we are going to discuss about the concept, okay, called multiplexing. Okay, we are going to implement a circuit for multiplexing, that we call it as multiplexer. Okay, common in the word what do you mean by multiplexing? Multiplexing complex. The meaning in it. Generally, the word we have heard about it. Multiplexing means what? Multiplex complex. Small cinema hall. Very good. Okay. See, that means you will be having many number of inputs. Okay. From that, we are going to take only one as output. Okay. In other words, we can say multiplexing is the process in which multiple data streams coming from different sources are transmitted over a single channel. Okay. See, I am going to have multiple inputs, okay, which are going to be made as a single output using a term called multiplexing. Okay, see, but all the signals can be seen by the person or select by a person, but only one at a time. Okay, even though we are having many uh, screens on your multiplex cinema hall, you can watch only one at a time. Is it clear? Is it clear or not? Many inputs we will be going to have, but we will be going to have only single output. Okay, that means multiple signals or streams or data, whatever it may be, it is multiplexed as a single channel. Okay, the process in which multiple data is converted into a single data, that we call it as multiplexing. Is it clear for all of you? Is it clear for all of you? Yes. Okay, now, so this is the symbol, basic symbol used for mux. Okay, so you can also call the multiplexer as mux. Okay, so here you will be going to have many inputs like this. Okay, you will be going to have many number of inputs based upon your requirement. Fine, but we will be going to have only one single output, which is multiplex. What do you mean by multiplexed? Even though it is a single output, it contains the mixing of all the inputs in certain way, in a certain way. Say for example, you will be having more number of FM stations, correct? So nama radio lo pathina more number of FM and AM stations will be there, correct? Fine. In that, how many outputs we are getting in our radio at a time? How many outputs we will be getting at a time? Many telecasters, okay, say for example television TVs, okay, they are transmitting their particular signal over a satellite, okay, but at a time how many output we are seeing in our television? Yes, even though we are having multiple channels, okay, channel is the correct word we can use. Okay, many inputs, for each input you will be having a separate channel. Clear? In the case of radio means in that case, channel is termed as frequency. Okay, say for example 98.5 megahertz. That particular frequency, if you choose, you will get a particular radio channel. Is it clear for all of you? Fine. When we are having multiple inputs, we have to get only one output. Okay, so we have to provide a mechanism to select from many to one. See, நமக்கு நிறைய inputs இருக்குது, அதுல ஏதோ ஒரு output தான் நமக்கு at a timeல தேவைப்பட போகுது, கரெக்ட்டா? So we have to use some mechanism to select out of that many to one. Okay, so in simple words we can say multiplexer அப்படினா many input signal. Okay, we will be going to have many number of input signal but single output. Fine, with an additional provision I will tell you later. Fine. So now we are going to consider a circuit. Okay, a circuit which is used for multiplexing the signal, that we call it as multiplexer. So multiplexing means mixing of many signals over a single line, or transmission of many channels over a single line, that we call it as multiplexing. To implement, we are having a digital circuit that we call it as multiplexer. Okay, so a digital multiplexer is a combinational circuit that selects binary information from one of many input line. Okay, see, நமக்கு many input line இருக்கு, அதுல ஏதோ ஒண்ணுத்த மட்டும் தான் நம்ம என்ன பண்ண போறோம், choose பண்ண போறோம். Fine, and transmit to a single output line. So many input to one output. That is the concept of multiplexer. Fine. The selection of a particular input line is controlled by a set of selection lines. Okay, so here also we are having control lines. See, எனக்கு inputs இருக்கு, output இருக்கு, கரெக்ட்டா? Many inputs சொல்லியாச்சு, single output சொல்லியாச்சு. From that many input, how we are going to choose a single output? With the help of this control line called selection line. Okay, you can see this pictorially. You consider there are 2 power n inputs but only one output. It need not to be 2 power n. Okay, you may have any numbers, but in general, in digital electronics, we'll be having the numbers in terms of powers of 2. The number of inputs is mentioned here in powers of 2. Okay, 2 power n means what we can do? What are the values we can put for n? Minimum n oda value enna irukanumpa? Minimum what must be the value of n? Yes, very good, 1. Yeah? Multiplexing அப்படின்னு சொன்னோம்னா definitely inputல எனக்கு என்ன இருக்கணும்? More than one signal must be there. Clear? இப்போ நான் n equal to 0 போட்டா எனக்கு என்ன ஆயிடும்? One signal, one output. So it is not a multiplexer. Minimum எனக்கு என்ன இருக்கணும்? More than one input must be there. Fine? So இப்போ inputs என்னென்ன இருக்கலாம்? Number of inputs எப்படி இருக்கலாம்? Can you type it in the chat? Can you type it in the chat? 2 power n means what are the possible number of inputs we can give? Kindly type it in the chat. 2 power 1, 2, 2 power 2, 4. Jeevitha, 1 kadayadappa, 1 varakudadu. What I told, multiplexer means more than one input must be there. Clear? Is it clear or not? Okay, fine. Kindly correct it, Sabriseti. Okay. 2 too many. Minimum 2 inputs must be there. 2 too many. Fine. Now, 2 power n input lines we are having. Fine. How many outputs we will be having in the case of multiplexer? How many outputs we will be having? Only one. Very good. So, one output line which is a multiplexed output. Fine. So, one more thing must be there in the block. What I told in the previous slide. How we can select an output from a 2 power n input. What we must be having? See, input line irukku, output line irukku, correct? Which input must be available at the output? For selecting that, we have one signal. What is that? Just in before slide, I have told you. Multiple inputs, yes, very good. Selection line, very good. So, we are having n select line. Okay. Why n select line? There is a relation between this. 2 power n input line irukku appadina, we must be having n select line. Because with n number of input, you can have 2 power n combination. Is it correct? Okay. So, we will be having n select line. Is it clear for all of you? This is the general block diagram of a multiplexer. It is not a circuit. It is the general block diagram of a multiplexer. Kindly take a screenshot. Shall I move to next slide? Shall we move to next slide? Yes. Okay. So, we can see an example. Fine. Here we have an audio output system. Okay. So, surround sound system we are having. Fine. For this, I am having the source from 4 devices. Okay. One is MP3 player, docking station, then laptop, then digital satellite receive the sound. Fine. Then digital cable TV. Fine. We are speaking about only the audio. This is for an example. For example, fine. Nalla gavanikkalam. Here we are having 4 inputs. Correct? In our case, we are having 4 inputs. So, what must be the number of select line? 4 is equal to what? 2 to the power 2. Correct? 2 to the power 2. So, n is equal to what? 2. So, we are having 2 select lines. B and A. Okay, we are having 2 select lines. Alla gavaninga, how it is going to provide the output? If the inputs B and A are 0, 0. Okay, if the inputs B and A are 0, 0, from this device, the audio signal is getting to the sound system. That is from MP3 player. Correct? If the input is 0, 1, that means if the select line condition is 0, 1, then it is from the laptop. Okay. So, from the laptop, the audio is going to an input to the surround system. Clear? So, we will be having only one output, but we are having multiple inputs. Is it clear for all of you? Is it clear for all of you? So, multiplexer oda use enna purinjudha? Yes. Okay. In your next semester, you will be studying microprocessor and microcontroller. there we will be using this particular concept. Okay, somewhere we will use this particular concept called multiplexer. Okay, is it clear? What is the advantage of multiplexer? Can you type it in the chat? Say for example, if I want to send the data from 4 devices, how many transmission lines I am in need? Very good question, Srihari. Very good question. In case of 5 input, okay. So your input is 5, correct? You are asking if it is not in terms of powers of 2. What we have to do is, you have to write 2 power 1, okay, 2 power 2, okay, 2 power 3, fine, then 2 power 4. You consider, in this case, you can have only 2 devices as an input, correct? In this case, you can have 4 devices as input, okay? In this case, you can have up to 8 devices. We don't have the thing for 5. So what we can do? We can go with this one, 2 to the power 3. That means 8 input, 1 output multiplexer. 8:1 multiplexer. How many select lines must be there? 3 select lines. Fine? Is it clear? So what about the remaining combination? Remaining combination எனக்கு என்ன ஆகும்? We may not use it. See, நம்ம டிவில வந்து நம்ம பார்க்குறோம் இல்லைங்களா channels, whether we are getting all the channels for all the numbers, where we are getting, yes, don't care terms. Okay, if you choose a particular channel, there is no telecast of a TV program, you may not see anything. Just blue screen தெரியலாம், இல்ல வந்து என்ன இருக்கலாம், just mosaic screen மாதிரி தெரியலாம், just white and black dots மட்டும் தெரியும். Clear? Is it clear now? Yes? But it's a good question. Okay, 2 power n சொன்னா multiples of, powers of 2 ல தான் இருக்கணும்னு கிடையாது. It may be any number. Okay, but we are having the multiplexer with the numbers in terms of powers of 2 only. Okay, clear? 2 power 2 power 2 power 1 we can use for 5 inputs. I can't get you, Sabarish.
Sir, 2 raised to 2 into 2 raised to 1 we can use 5 inputs.
What you are asking is 2 power 2 is to 2 power 1. 2 power 2 is 4 into 2 is 8 only, na? 2 power 2 is 4 multiplied with 2 power 1 is 8 only, na? Okay. See, I will later point of the time, I will take something in the board. During that time, I will explain you few more things. Okay, fine. As of now, whether it is clear? Many inputs, single output with select lines. Okay, the number of inputs is generally in powers of 2, so that the select line is n. Okay, so 2 to the power input, 2 to the power n input, 1 output, n select line, that's it. So in this case, 4 inputs, okay, 1 output, 2 select line. Fine? So that's what we are going to discuss here. So example, a multiplexer with 16 input lines, that means 2 raised to the power 4 requires 4 selection line to select one of the 16 inputs. So we'll be going to have only 1 output. So multiplexer is also called as data selector. Why? Multiplexer ki innor name enna solranga appdin pathina data selector appdin solranga. Why? This particular circuit is used to select an information from many inputs, correct? So that's why it is termed as data selector. Okay, in short, it is abbreviated as MUX. So generally the MUX appdinu sollalam already nama sollirukom. Is it clear for all of you? Is it clear? Okay, can you type it in the chat? If I am having 12 inputs, okay, what is the size of the multiplexer I have to go with? If I am having 12 inputs, number of input is 12. 12 input means 12 inputs. So what about the size of the multiplexer? n is equal to 4. Very good. So n is equal to 4. That means 2 to the power n is equal to 16. So 16 is to 1 mux. We have to go with 16 input, okay, 1 output mux with 4 select lines. 4 select lines. 4 select lines. Fine? Okay. So we will move to next slide. We will first go with 2:1 mux. Okay. So 2:1 mux அப்படினா எத்தனை input இருக்கணும்ப்பா? How many number of inputs must be there? The first number indicates the number of inputs. So 2 inputs. Okay. So I0, I1. We are naming it as input 0, input 1. I0, I1. Okay. Fine. So how many output must be there? Number of output எவ்வளவு இருக்கணும்ப்பா? 1. Okay. See, நல்லா கவனிச்சுக்கோங்க. The first number indicates the number of input. Okay. The second number indicates the number of output. So in this case, we will be having only one output, that is Y. Okay. Now you type it in the chat. How many select lines I must be having? How many select lines I must be having? Very good, Priyanka. Only one select line. We are naming it as yes. Clear? See, அப்போ multiplexer அப்படின்னு சொன்னோம்னா the block diagram representation should be like this. Clear? So first என்ன பண்ணோம், ஒரு block நம்ம போட்டாச்சு, correct? Then 2 inputs I0, I1, then 1 output, then n select lines. Okay, here we are having n is equal to 1 because 2 is equal to what? How we can represent 2 in powers of 2? 2 to the power 1. Okay, so n is equal to 1. That's it. Clear for all of you? Yes? Shall we proceed? Can we tell AND gate 2 switch 1 input as an example, sir? AND gate 2 switch 1 input as an example. See, AND gate, it is producing a logical output. It is not selecting the data. Is it clear, Sabarish? See, AND gate is something different. Okay, it is performing a logical operation of 2 inputs. Okay, and produces an output. Okay, we cannot call it as multiplexer because it is not going to be used as a multiplexer. Say for example, எனக்கு ஒரு AND gate இருக்குன்னு எடுத்துக்கிறோம். Okay, so இது என்னோட AND gate அப்படின்னு எடுத்துக்கிட்டோம்னா we will be having 2 inputs. What he is asking is, so அதுல நமக்கு 2:1 தானே இருக்குது அப்படின்னு கேட்கிறோம். We are taking the inputs as x and y. So always what it will produce? The logical operation of x and y. Here there is no point of selecting the inputs from this side to this side. Okay. So this may not be a mux. This is not a mux. Okay. See, number of inputs, outputs வச்சு மட்டும் நம்ம என்ன பண்ண முடியாது. We may not say it is mux. Okay. It must have a provision so that it selects from any one of the many inputs. Okay. Fine. Next. Kindly take a screenshot. I will move to the next slide. Kindly take a screenshot. I will move to the next slide. Yes? Shall I proceed? Yes. Okay. Now, truth table for a 2:1 multiplexer. Okay. So, the diagram வச்சு first சொல்லிடலாம். Fine. So, இதில் நமக்கு வந்து பார்த்தீங்க அப்படின்னு பார்த்தீங்கன்னா ரெண்டு கண்டிஷன் தான் எடுத்துக்க போகிறோம் இந்த ட்ரூத் டேபிள். ஒன்று வந்து என்ன அப்படின்னு பார்த்தீங்கன்னா we'll see the truth table straight away. Okay. So select line S எடுத்துக்கிறோம், கரெக்டா? So this is our select line and we will be having the output as Y. நல்லா கவனிங்க, if S is equal to 0, what will be my output? I0. If S is equal to 1, what will be my output? I1. From this diagram you can see. See, if I keep S is equal to 0, okay, this output I0 must come as output. Y is equal to I0. Clear? Suppose if S is equal to 1 means, this must come as output. Y is equal to, sorry, here it is I0. Okay. So Y is equal to I1 for this case. Is it clear for all of you? Is it clear for all of you? என்னோட select line 0 இருந்துச்சுன்னா 0th inputல என்ன இருக்கோ channel என்ன இருக்கோ that will be available at the output. Okay, if I am putting 1, the select line logic 1 இருந்துச்சுன்னா the second channel, that means I1 must be coming as the output. Is it clear? Yes or no? Yes. Okay. Now we have to write the function, output function y. y எப்ப எனக்கு I0 வரலாம் அப்படின்னு பாத்தீங்கன்னா when s is equal to 0, the input I0 is available at the output line, correct? When s is equal to 1, the input line I1 is available at the output line, correct? This is the condition. Okay, now you consider we are having only one input, okay, and one output. Fine. So generally இங்க நம்ம என்ன fill பண்ணுவோம் இப்போ outputல what value we must fill in the output? Generally truth table la enna value நம்ம fill பண்ணுவோம்? What are the values we can fill the output generally? இதுக்கு முன்னாடி நம்ம பார்த்த எல்லா truth table என்ன பண்ணோம்ப்பா 1 or 0. But இங்க என்ன நம்ம போட்டுருக்கோம் I0 I1. It is very simple. Okay, so I0 அப்படின்னா meaning என்னன்னா when I0, when s is equal to 0, that means how we can treat it as s bar dot I0. Fine, that's it. Similarly, plus when output is equal to I1, s dot I1. So this is the output function I will be having. Sorry, I1. So this is the output function I will be having. Is it clear? Generally இங்க 1 போட்டுருந்தா என்ன பண்ணுவோம்? வெறும் s bar னு எடுத்து எழுதுவோம். கரெக்ட்டா? இங்க 1 போட்டுருந்தா என்ன எடுத்து எழுதுவோம்? Simply we will write it as s. Here is some value we are having. See, generally இந்த function எப்படி எழுதுறது அப்படினு பாத்தீங்கன்னா that output ANDed with this combination. Say for example, இந்த truth table எடுத்துக்கலாம். A B I am considering A B. Okay, so we will be having the possible combination as 0 0 0 1 1 0, then finally 1 1. So randomly I am filling some ones here. Okay, 1 0 1 1. If it is like this, நல்லா கவனிக்கணும். இதுக்கு நம்ம என்ன எடுத்து எழுதுவோம் ஞாபகம் இருக்கா? What minterm we will write for this one? A bar dot B bar. Is it correct? Actually dot 1 we must write. The output என்ன வருதோ அதையும் நான் என்ன பண்றேன் dot 1 we must be writing. இங்க 1 இருக்கிறதுனால தான் dot 1. இங்க நமக்கு என்ன இருக்கு? We are having I0. So what we are writing? S bar dot I0. இங்க என்ன இருக்கு? 1 இருக்கு. So S dot I1. Whether it is clear for all of you? What I am saying, whether it is clear for all of you? Yes or no? Yes. If we are having only 1, we are writing the minterm directly. If you are having 0, we are neglecting that minterm. If you are having some variable in the output, at the time what you have to do? Minterm ANDed with that variable. That's it. So that is the thing we have to do. Clear? Is it clear now? We will implement the circuit and we will check it. Srihariku puriyalannu nenikiren. Fine. I will explain you one more time, Srihari. Here you consider what is the minterm for this one. Okay, we will consider the last one. I will change the color of the pen so that you can understand. Okay, now we will consider this combination of input and output. Fine. So here we are having the output as 1. So what about the function for this output 1? Minterm enna varum pa enakku? Kindly type it in the chat. Srihari. A equal to 1, B equal to 1. Output 1 இருக்குது. கரெக்ட்டா? So what about the minterm? Canonical form எழுதுறதுக்கு சொல்லி கொடுத்திருக்கோம் இல்லீங்களா? The variable is normal form. A அப்படியே எழுதிக்கலாம். B அப்படியே எழுதிக்கலாம். Yes, very good. A dot B. Correct? A dot B. What I am saying is you have to AND the output also. இந்த 1 நான் இது கூட AND பண்றேன். That is the meaning for this. So A dot B dot 1 is equal to what? Simply AB. So in the case எனக்கு என்ன வரும் பாருங்க. What about the min term for 1 0? What about the min term for 1 0? Can you type it in the chat? A equal to 1, B equal to 0. அப்படின்னா min term என்ன? A B bar. Okay, A dot B bar. B bar dot, what is my output in this case? What is my output in this case? What is my output? 0, correct? So dot 0 if you put, what about the final result? This min term won't come for this function. Is it correct? Is it clear now, Srihari? Yes. So the same thing what I am saying here is, here we are having S equal to 0 means output is not 1 or 0, it is I naught. So how I can write? For S, if it is 0, S bar dot I naught. Is it clear? Okay. Here also I am not having 0, I am having I1. So what we have to write? S is equal to 1, that means S dot I1. If I naught or I1 is equal to 0, it must be replaced there. That's it. Is it clear now? Is it clear now? Yes? See, from this truth table, you have to write the output function y is equal to, we are having only one output, na? Sum of all the min terms we have to do. Here we are not having neither 1 nor 0. We are having some other variable name. So in that case, you have to write like this. Is it clear? Yes. Okay. Now I will move to the next slide. Okay. So Boolean equation from the truth table is y is equal to S bar I naught plus S I1. So what about the logic diagram? We are having two inputs, I1, I naught. Okay. I have drawn. Then we are having one select line S. Okay. From the select line, you have to take the normal form as well as the complement form like this. Okay. So S ல நான் ஒரு NOT gate போட்டு எடுத்தேன்னா அவுட்புட்ல எனக்கு என்ன கிடைக்கும்? S bar. இந்த NOT gate முன்னாடி எனக்கு என்ன இருக்கும்? The same value S. Clear? Fine. Then we have to perform two under terms. We have to perform two under terms. S bar I naught, S I1. Okay. So அப்ப S எது கூட நம்ம AND பண்ண போறோம்? I1 கூட AND பண்ண போறோம். S bar we are going to perform AND with I0. So the circuit will be like this. Is it clear up to this? Is it clear up to this? See, இந்த மாதிரி diagram வரைஞ்சோம்னா ஈஸியா இருக்கும். Is it clear? Yes. Okay. So finally what we need to produce the output? Y எனக்கு வேணும். Which logic gate I can use? Y is equal to what? S bar I1 plus S I1. So which logic gate I can use? OR gate. Very good. So you will be having the output like this. Is it clear? Now I am going to enclose the entire thing. Okay. Now I am going to enclose the entire thing as a block. Fine. So we are having two inputs. Okay. We are having one output. Okay, we are having one select line. So this entire circuit, okay, can be represented like this. Like this. Like this. So the black box, in the box kulla enna irukudhu? In the circuit da irukudhu. Is it clear? See, in digital electronics, if you are using a component repeatedly in some other circuit or project, you can represent it as a block diagram. Okay, logic diagram. Okay, logic diagram means you have to draw the entire circuit. Okay, block diagram means what? Simply you draw the block. That's enough. Okay, fine. Sabrisati, I think you have typed plus. Sabrisati, you have. Oh, for OR gate. Okay, okay, fine, fine. For OR operation, you have told plus. Okay, fine. Okay, now we will move to 4:1 merge. Now you tell me how many inputs must be there? How many inputs must be there? Number of inputs எத்தனை இருக்கணும்ப்பா? 4 input, 1 output. Very good. 4 inputs, I3, I2, I1, I0. Okay. Then we are having only one output named as Y. How many select lines must be there? How many select lines we must be having? எத்தனை select line எனக்கு இருக்கணும்? Very good. 2 select line. Fine. 2 select line. Okay. Good. Now we can design. So to design this, we must be having the truth table. Fine. நல்லா கவனிங்க. S1 S0 0 0 இருந்தா I0. See, இது எப்படி நம்ம ஈஸியா வந்து அண்டர்ஸ்டாண்ட் பண்ணிக்கலாம் அப்படின்னா 0 0 இந்த காம்பினேஷனை டெசிமலுக்கு கன்வெர்ட் பண்ணுங்க. 0 0 டெசிமல் கன்வெர்ட் பண்ணா எனக்கு என்ன கிடைக்கும்? 0. So I0. Fine. For example 1 1. If you convert this 1 1 as a decimal number, we will be getting 3. Correct? Is it clear? Is it clear or not? Just நம்ம என்ன பண்றோம் இந்த input, see how this combination of input is assigned for our output is like this. Okay, now can you type it in the chat? What about the output function y? Output function y என்ன வரும் டைப் பண்ண முடியுமா? This output function y. For first one I will write the term. For first one what will be the term we will be having? S1 bar, S0 bar, I0 for the first one. Plus, like that you write for the entire thing. What about the function we will be getting for y? Y is equal to what? Kindly type it in the chat. What about the expression for y? You take some time and type it. Okay, because your response is very important for me. Okay, whether you have understand how to write the function for this. நார்மலா 1 0 போட்டுருந்தா மின் டேர்ம் மட்டும் எடுத்து எழுதி ஆட் பண்ணிடுவோம். கரெக்டா? ஃபைன். இங்க நமக்கு 1 இல்ல 0 இல்ல. Yes. Remaining terms are yes. S1 காணும்பா, S0 காணும். Simply SS ன்னு இருக்கு. So you have to use with some naming. Okay, so this one is S0. Okay, so the expression is like this. So what Sabarisheti is tried is correct, but numbering வந்து ப்ராப்பரா இல்ல. Fine. So S1 bar, S0 bar, I0. Fine. S1 bar, S0, I1. S1, S0 bar, I2. S1, S0, I3. Is it clear for all of you? Is it clear for all of you? Now kindly type it in the chat. Now kindly type it in the chat. How many NOT gate, how many AND gate, and how many OR gate I must be having? To perform this operation, எனக்கு எத்தனை AND gate வேணும், எத்தனை OR gate வேணும், எத்தனை NOT gate வேணும்? Kindly take a screenshot of this. Kindly take a screenshot of this. I will move to next slide. Yes, 2 NOT gate. Very good. So I0, I1, I2, I3, S1, S0 இருக்கு. So to generate the output, S1, S1 bar, S0, S0 bar, we need only 1 NOT gate. Sorry, 2 NOT gate. Clear? Fine. How many AND terms we have in the expression? How many AND terms? 4 AND terms. Very good. So 4 AND terms. So the expression coming like this. Okay. But notice one thing. The number of inputs for the AND gate is 3 inputs. Okay. What about the OR gate? Number of inputs for the OR gate? How many OR gate we need? 3 inputs or 4? Respond. Kindly check it. We are having 4 things to be ORed. Yes, very good, Srigari. 4 inputs must be there for our OR gate. So the final expression will be like this. Fine. So here also you can convert this as a block. Block diagram ne ketta neenga idu mattum pota podum. Fine. Sorry. So we will be having a thing like this. So this entire block we term it as 4:1 much. Okay, so we are having 4 input lines. Okay, 1 output line, then 2 select lines we are having. So like that you can design circuit for what? 8 is to 1, 16 is to 1, like that you can go for. Clear? Is it clear for all of you up to this? புரிஞ்சுதாப்பா இது வரைக்கும் எல்லாருக்குமே? Yes, okay. Now we will move on to next slide. Kindly take a screenshot of this. Your screenshot எடுத்துக்கோங்க. We will move to next slide. See, இந்த diagram வரையறதுக்கு ஈஸியான மெத்தட் தான் நாங்க இங்க ரெப்ரசன்ட் பண்ணியிருக்குது. ஃபர்ஸ்ட் செலக்ட் லைன்ல என்ன பண்றோம்? For each select line you have to place a NOT gate. Okay, then you go with AND gate. Then you go with OR gate. Okay, I will move to next slide. Fine. So here you are asked to implement the Boolean function. Okay. So in the function வந்து implement பண்ண சொல்லியிருக்கிறோம். We are going to implement this function. Okay. Sum of 0, 2 using 4:1 multiplexer. Okay. So 4:1 multiplexer block diagram first நம்ம draw பண்ணியாச்சு. Is it clear for all of you? Is it clear for all of you? Yes or no? Yes. Okay. So using this multiplexer, we are going to implement the Boolean function for sigma of 0, 2. How we can implement? Any idea? Any idea? Simple procedure. What are all the min terms we are having? What are all the min terms we are having? என்னென்ன min terms இருக்கு? I0, I2. So இப்போ எந்தெந்த காம்பினேஷனுக்கு எனக்கு அவுட்புட் 1 வரணும்? X bar, Y bar. கரெக்டா? X bar, Y bar. இதுக்கு அவுட்புட் வந்து 1 வரணும். கரெக்டா? What about the other combination? X, Y bar. Is it correct or not? Is it correct or not? சொல்றது புரியுதுங்களா? எந்தெந்த காம்பினேஷனுக்கு அவுட்புட் 1 வரணும்? So f is equal to, this is the function we will be having, f is equal to x bar y bar plus xy. Correct? So here you consider this variables are nothing but you are going to use your select lines. You consider s1 is equal to x. Okay. Then s0 is equal to y. Simply you consider like this. So the meaning என்ன? 0, 0. S1, S0, 0 இருந்தா meaning என்ன? If both S1 and S0 0 இருந்தா எந்த output எனக்கு வெளியில வரணும்? I0. Clear? If it is 1, 0. Okay, if it is 1, 0. If the select lines are 1, 0. I2 எனக்கு வெளியில வரணும். Correctா? So what we can do? It's very simple. Just I0, I2. இதுக்கு ரெண்டும் வர இன்புட்ஸ் நான் என்ன பண்ண போறேன்? I am going to making it as 1. Is it clear? Logic 1 means plus 5 volt we can give at that pin. The block diagram la logic 1 constant value I am giving at the inputs I0, I2 la நான் டைரக்டா என்ன பண்றேன்? 1 அப்ளை பண்ணிறேன். What about I1 and I3? What about I1 and I3? For that combination, what output I must get? For that combination, what output I must get? Logic 0. So we are connecting logic 0. இது யாருக்காவது புரியலன்னா தயவு செஞ்சு கேளுங்க. சிம்பிளா எனக்கு இது கான்செப்ட்லாம் எனக்கு வேணாம் சார், இந்த மாதிரி கொஸ்டின் கேட்டா எப்படி ஆன்சர் பண்றது? ஓகே, ஃபார் த மின் டேர்ம் 0 and 2 it is given in the function. ஸோ அதுக்கு கரஸ்பாண்டிங் இன்புட்ஸ் எல்லாம் 1 பண்ணிட்டு ரிமைனிங் இன்புட்ஸ்லாம் என்ன பண்ணிடுறோம்? ஜஸ்ட் 0 பண்ணுங்க. தட்ஸ் இட். ஓகே, நவ் யூ கன்சிடர் மின் டேர்ம் 0 கொடுத்தா எனக்கு என்ன வரும்? 0னா என்ன சொல்லியிருக்கோம் இங்க? S1 0, S0 0. கரெக்டா? 0 0 இருந்தா எந்த அவுட்புட் வெளியில வரும்? This one will come as output. 1 கிடைச்சிருமா? Correct? Fine. Next condition பார்க்கலாமா? Next condition. So next condition is, you consider some other condition. For 2, okay, 2 means what? S1 is equal to 1, S0 equal to 0. So for 1 0 combination, this output will come as the output. So here also we are having 1. So we will be having the output as 1. So the functionality புரிஞ்சுக்கணும், அதுக்காக தான் இதை எக்ஸ்பிளைன் பண்றேன். Clear? So இப்போ ஒரே ஒரு விஷயம் புரிஞ்சுதா? You can implement any boolean function using multiplexer. Clear? For each function you have to use one multiplexer. How to select the size of the multiplexer? Can you type it in the chat? Size of the multiplexer depends on what? To implement inputs. Okay, we are having two inputs. Okay, x y, two inputs. Correct? So இப்போ எனக்கு என்ன select line இருக்கணும்? Two number of select line இருக்கணும். So இப்போ என்ன marks? 4:1. That's it. Number of select line variables அப்படின்னு சொன்னோம்னா number of select line consider பண்ணிக்கோங்க. To design or to implement any boolean function with n variables, you must have n select lines. Clear for all of you? Is it clear for all of you? Yes. Okay. Now we will move on to next problem. Fine. So next problem la enna kuduthirukanga parunga 1 2 6 7 x y z 1 2 6 7. Okay. So for x can you type it in the chat? So inge nama kuduthachu 8:1 appdin kuduthachu. Correct? Clear how it is 8? So we are having three variables. Okay. So we are going to have s2, s1, s0. So we are having three select lines. So 2 to the power n inputs. So n is equal to 3 in this case. So we are having 8:1 multiplexer. See, suppose question la idu kudukalanalum just in the word vittirukanga vechukonga. Just you assume it is like this. It is not there in the question. So you have to choose the proper size of the multiplexer if it is not mentioned. So what we have to use? 8:1. Clear? So idellame namakku 2 mark la kekkalam. What must be the size of multiplexer? You can choose for implement this particular boolean function. So three variables irukku, three select lines, so 8:1 multiplexer. Solution paakalaங்களா? So this is the block diagram of 8:1 multiplexer. Okay. Now you type it in the chat. What are all the things you have to made as 1 and what are the things you have to made as 0 in the input side? Input side la edadella 1 பண்ணனும், edadella 0 பண்ணனும்? Kindly type it in the chat. Zero, 1. I can't understand you, Sabarish. See, what I am asking is, from the input side, what are the things are connected to logic 1? What are the things are connected to logic 0? Dear students, I have got one information. Okay, some of you are doing some other work during this class hour, so you will be given absent for this class. Say for example, the roll numbers 108, 112, 224, 217, 236, 126. You people are doing some other work during this class hour, so I will inform this to your concerned HOD. Okay. See, ஒரு கிளாஸ் நம்ம எடுக்கிறப்ப இன்னொரு வேலை பண்ணிட்டு இருக்கீங்க அப்படின்னா, what is the point of this class? See, நமக்கு எதுவும் தெரியாது அப்படின்னு நினைக்க வேண்டாம். We know what you peoples are doing in the background. Okay. Thank you, Reswan and Soumya Ravi. 1, 2, 6, 7 as 1 and remaining as 0. Very good. 1, 2, 6, 7. இது என்ன பண்ணணும்? 1 பண்ணணும். The remaining things we have to make it as 0. Very good. Okay. So you both are correct. Is it clear for all of you? Is it clear for all of you? Okay. Shall we move to next slide? Shall we move to next slide? Yes. Okay. Now we are having a problem like this. The same problem. F of x comma y comma z is equal to sum of 1, 2, 6, 7. Okay. Note down this. How many variables we are having? 3 variables, but we are asked to do with 4:1 multiplexer. Fine? Fine? Difference purida pona question ku idukum. The previous question they have told 8:1. It directly matches with the given problem. Okay. But in this case, we are having 3 inputs, but we are asked to do with 4:1 multiplexer. Shall we proceed? Shall we proceed? Okay. Now you type it in the chat. For the 4:1 multiplexer, what are the input naming? Inputs enna kodupom? What are the 4 inputs we must be giving? What are the 4 inputs we must be giving for the 4:1 mux? Variable name assign pannom illaya? I0, I1, I2, I3. Correct? I0, I1, I2, I3. I am writing that variable, input variable of the mux as it is. இது புரிஞ்சுதா எல்லாருக்கும்? இது புரிஞ்சுதாப்பா? Yes, very good Sabrisity. I0, I1, I2, I3. Fine. இதுல ஒரே ஒரு விஷயம் நல்லா கவனிக்கணும். So I have told you, you have to assign this variable as a select line. But நமக்கு எத்தனை select line இருக்கும் இதுக்கு? How many select lines we will be having for this multiplexer? Kindly type it in the chat. 2. So I am going to consider only 2 variables from the last. From the last means z and x. இது ரெண்டு மட்டும் எடுத்துக்க போறோம். Okay. So x வந்து நான் என்ன சொல்றேன்? y வந்து என்ன சொல்றோம்? S1. z வந்து என்ன சொல்றேன்? S0. So missing variable எது இதுல? What about the missing variable we are having? From the 3 variable, ஒரு variableக்கு select line கிடையாது. எந்த variable? X. Very good. So I am going to write the variable as in complement form and normal form. X bar X. Is it clear? Is it clear? Is it clear? Yes? Okay, fine. So I am going to draw a line like this so that we can have some format. Okay. So in the table க்கு பேர் என்ன அப்படினு பாத்தீங்கன்னா implementation table அப்படினு சொல்றோம். Okay, when we have to go with the implementation table, if the number of variables is not equal to the number of select line, okay, we have to go with implementation table. Fine. Now we are going to write the number. இங்க I0 க்கு meaning என்ன அப்படினு பாத்தீங்கன்னா y bar z bar. I1 க்கு meaning என்ன அப்படினு பாத்தீங்கன்னா y bar z. I2 க்கு meaning என்ன அப்படினு பாத்தீங்கன்னா y z bar. Okay, I3 க்கு meaning என்ன அப்படினு பாத்தீங்கன்னா y z. Fine. இது புரிஞ்சதா எல்லாருக்கும்? Yes or no? See, I am going very slower. Why I am going very slower? You people are responding very rare. Only 3 or 4 people are responding. Okay. It's not like K-map Sabris. You should not confuse with this implementation table with K-map. K-map Madri, but it is not K-map. Please understand that. What I am saying is, it is not exactly K-map. Okay, fine. இது புரிஞ்சுதா எல்லாருக்குமே? Yes? Yes or no? Yes, okay. Now, so I am going to write the min terms. என்னென்ன min terms லாம் இருக்கு x, y, z க்கு? 0, 1, 2, 3, 4, 5, 6, 7. Correct? 0 னா மீனிங் என்ன? நல்லா கவனிச்சு பாருங்க. x bar, y bar, z. 1 னா மீனிங் என்ன? x bar, y bar, z. 2 னா மீனிங் என்ன? x bar, y, z bar. மேட்ச் ஆகுதா? Like this you have to fill it. Don't follow gray code pattern here. Sabris கேட்டது அதுதான். Sir, K-map table மாதிரி அப்படின்னு கேட்டாரு. It is like K-map, but it is not exactly K-map. Okay, this we call it as implementation table. Is it clear up to this? Is it clear up to this? Yes, okay. Now, next step என்ன பண்ண போறோம் அப்படின்னு நான் சொல்றேன். You have to mark what are all the min terms we are having in the function. என்னென்ன min termலாம் இருக்கு? 1, 2, 6, 7. Please carefully observe. Okay. 1, 2, 6, 7. So, அதெல்லாம் நான் என்ன பண்ணிருக்கேன்? I am just circling it. Fine. Now, vertical we are going to take the OR operation. Vertical எடுக்க போறோம். So, இதுல ரெண்டுமே மார்க் ஆகல. கரெக்டா? Neither 0 nor 4. கரெக்டா? So, இதுல நமக்கு எந்த ஒரு டேர்முமே கிடையாது. So, we are writing it as 0. Fine. Next, in the second column, from here we are going to write. In the circle நேரா என்ன இருக்கு பாருங்க, we are having x bar, correct? Is it clear? So what we are going to write is x bar alone. X bar alone. Okay. 2, 6. ரெண்டுமே கவர் ஆயிருக்கு. அப்ப மீனிங் என்ன? x bar plus x. What about the value? Kindly type it in the chat. Very good response. 1. Okay, very good. I think போனதுக்கு நீங்க சொன்னீங்கன்னு நினைக்கிறேன். So இங்க 1 இருக்குது இல்லையா, எதெல்லாம் சர்க்கிள் பண்ணிருக்கோமோ இந்த ரோ you have to consider which term we are having only x bar. இது சர்க்கிள் ஆகல, அதனால இதை விட்டாச்சு. கரெக்ட்டா? What about here in this case? x bar இருக்கு, x இருக்குது. That means in a column, if all the things are circle, so we can write it as 1. In other words, we can say x bar plus x. It is x bar plus x. புரிஞ்சுதா இது? What about for the last one? Can you type it in the chat? X. Very good, Jivita. So in general, by concluding this particular implementation table, you can have like this. I0 must be 0, I1 must be x bar, I2 must be 1, and I3 must be x. Is it clear? Is it clear up to this? Shall we go for logic diagram? Okay. ரொம்ப சிம்பிள். நல்லா கவனிங்க. I0 அப்படின்ற இன்புட்டுக்கு நான் என்ன பண்ணிடணும்? Kindly check it. I0 equal to 0. So, 0 போட்டாச்சு, முடிஞ்சு போச்சு. I0 equal to 0. அடுத்து I1 equal to x bar. So, x னு ஒரு வேரியபிள் வச்சு நம்ம என்ன பண்றோம்? We are complement. Here we will be having x bar. What about I2? I2 we are having 1 here. What about I3? We are having x here directly. Okay. Now we will check. We will give input as 6. 6 கொடுத்து பார்க்கலாமா? 6 னா மீனிங் என்ன? 1 1 0 கொடுத்து பார்ப்போமா? So here I am going to give 1. So இங்க 1 கொடுத்தா இங்க எனக்கு என்ன வரும்? 0. இங்க என்ன வரும்? 1. Okay. சரி, இங்க ஆல்ரெடி 1 தான் இருக்கு. சரி. So here we will be going to have 1. கரெக்ட்டா? x 1 கொடுத்தா இந்த இதுக்கு எனக்கு என்ன வரும்? The complemented output will be having 0. Here straight away the 1 is coming. Okay. So இங்க நமக்கு என்ன இருக்கு ஆல்ரெடி? 1. இங்க 0 இருக்கு. கரெக்ட்டா? Fine. So 1 1 0. கரெக்ட்டா? இங்க 1 0 கொடுத்தோம்னா எந்த இன்புட் எனக்கு செலக்ட் ஆகும்? Can you type it in the chat? If I gave the input as 1 1 0, so 1 0 க்கு எந்த இன்புட் செலக்ட் ஆகும்? I0 I1 I2 ல I3 ல எது செலக்ட் ஆகும்? Yes, second one. Second one ல என்ன இன்புட் வந்திருக்கு? 1. So what about the output will be getting? 1. Clear? So if I give the combination 1 1 0, I am getting 1. Similarly 0 0 1 கொடுத்தாலோ இல்ல 0 1 0 கொடுத்தாலோ இல்ல 1 1 1 கொடுத்தாலோ அவுட்புட்ல என்ன வரும்? 1 தான் வரும். So this circuit will work. Fine. So now this entire thing, இதுல என்னோட இன்புட்ஸ் என்னென்ன? x, y, z are the 3 inputs. We'll be having the output function as f. So using multiplexer, you can implement any Boolean function. Even the size is not matching. At that case, we have to go with some new term called implementation table. Okay, new thing called implementation table. எப்பெல்லாம் என்னோட size of the multiplexer not matches with the given Boolean function variable அப்படின்னு சொல்றோமோ, that time you can go with implementation table. Is it clear for all of you? Yes. Sabri Sethi புரியலையா? Okay, I will explain you. So இது புரிஞ்சுதா? Up to this expression, whether it is clear? Sabri Sethi? Yes. Okay, just simply நான் என்ன பண்றேன் பாருங்க. I0 என்ன சொல்லிருக்கோம்? 0. So இப்ப straight away I0 என்ன பண்ணிட்டேன்? 0 கனெக்ட் பண்ணிட்டேன். கரெக்ட்டா? What about I1 x bar? So இப்ப x காம்ப்ளிமென்ட் பண்ணா எனக்கு என்ன கிடைக்கும் அவுட்புட்ல? I am having x bar as the input for I1. Fine. For I2 we will be having 1. Is it clear? 1. For I3 we will be having x straight away. Up to this, whether it is clear, Sabrish? Yes? Yes or no? Yes. Okay. Now you consider any one of the minterm and tell me. Already I have done for 6. You can tell some other minterm. 7. So if I use the minterm as 7, so what about the combination? 1, 1, 1. That means x is equal to 1, y is equal to 1, and z is equal to 1. See, இங்க நான் என்ன replace பண்ணிருக்கேன்? Already சொன்னேன். y என்னன்னு எடுத்தாச்சு? The line S1 தான் y ன்னு எடுத்திருக்கு. Line S0 தான் நான் என்ன எடுத்திருக்கு? Z ன்னு எடுத்திருக்கு. கரெக்ட்டா? So இதுதான் என்னோட S1. இதுதான் என்னோட S0. Okay. So what you have told is x, y, z எல்லாமே 1. கரெக்ட்டா? So x is equal to 1 கொடுத்தாச்சுனா இங்க எனக்கு என்ன கிடைக்கும்? x bar means 0. இங்க straight away x. So இங்க 1. Already இங்க என்ன இருக்கு? 0. Constant thing. Here I am having 1. Fine. So இங்க என்ன சொல்லியிருக்கோம்? 1, 1, 1 னா y is also 1. Okay. Z is also 1. In the case of the select line 1, 1, எந்த output select ஆகும்? The third output. That means fourth one, which is named as I3. I3 ல என்ன logic இருக்கு? 1 logic. So we'll be getting output as 1. Is it clear now? என்ன வேரியபிள் நான் டிசைன் பண்ணனும் யூஸ் பண்ணி சோ அதுக்கு நம்ம அந்த மின்டர்ம்ஸ் கொடுத்தா அவுட்புட்ல என்ன வந்துரும் ஆட்டோமேட்டிக்கா will be getting 1. Is it clear now? Yes. Shall I proceed? Yes, okay. Now, kindly take a screenshot of this. If time permits, at the end of the session, I will solve this problem. Okay. So, 4 input variables இருக்கு, correct? But mux வந்து 4:1 தான் யூஸ் பண்ணனும்னு சொல்லிருக்கோம். Fine? So, இங்க நம்ம என்ன பண்ணனும்? We have to go with implementation table. Then second problem, implement the full adder circuit using multiplexer. ரெண்டு question கொடுத்திருக்கோம். I2 also has one number. I can't get you, Srihari.
Sir,
see, I2 வந்து 1 இருக்குப்பா. எனக்கு புரியுது Srihari, நீங்க என்ன சொல்றீங்கன்னு. I2 வந்து 1 இருக்குது. பட் நம்ம இங்க கொடுத்திருக்க இன்புட் காம்பினேஷன் செலக்ட் லைன் என்ன காம்பினேஷன் யூஸ் பண்ணிருக்கோம்? 1, 1. From the 4 input, the last one is available at the output. இதுதான் வெளியில போகும்னு சொல்லிருக்கோம். Is it clear now, Srihari? Is it clear now?
I0 I2 க்கும் இங்க வந்து எந்த யூஸ் இல்ல சார்.
புரியல
சார். I0 I2 கான்ஸ்டன்ட்டா இருக்குல்ல சார்.
ஆமா, இப்போ நீங்க இப்படி எடுத்துக்கோங்களேன். ஃபார் எக்ஸாம்பிள் யூ டேக்
எந்த இன்புட் கொடுத்தாலும் I0 I2
நீங்க இங்க செலக்ட் லைன்ல என்ன கொடுக்குறீங்களோ அதை தான் நீங்க செக் பண்ணணும். You can have any inputs here. Okay, based on the select line. See, for example, இவர் 7 சொன்னாரு. 7 னா மீனிங் என்ன? x 1, y 1, z 1. கரெக்ட்டா? சோ இப்போ y z 1 1 அப்படினா மீனிங் என்ன? s1 s0 1 1 னா இங்க என்ன இன்புட் இருக்கோ அதுதான் எனக்கு அவுட்புட்ல கிடைக்கும், irrespective of the other inputs. Clear? மல்டிப்ளெக்சர் புரிஞ்சுதா உங்களுக்கு?
சார் நோ சார்.
ஏதோ ஒரு இன்புட் தான் அவுட்புட்ல நான் கொண்டு வர முடியும் அட் a டைம்ல. கரெக்ட்டா? சோ இப்போ நான் இந்த காம்பினேஷன் 1 1 1 கொடுத்தேனா x க்கு என்ன கொடுத்திருக்கோம்? 1. சோ அந்த 1 தான் இங்கேயும் வர போகுது. So this value is available at the output. From the 4 input, it is selecting the 4th input as output. Clear?
Sir, in the example board la kaminga sir. In the example board la kaminga sir. எழுதிட்டேன்.
இந்த எக்ஸாம்பிள் போர்ட்ல காமிக்கணுமா? சரி, ஓகே. 1 2 6 7. Okay, 1 2 6 7. Wait a minute. I'll display it from the board. Camera is on. What about the camera? Okay, wait a minute. Wait for some time. We'll log in again. Is the board is visible now?
No, sir, still not.
Yes? The
No,
board is
sir.
visible for
No,
all of
no,
you?
no. No.
No, no. Actually, I didn't present it, I think so.
Visible, sir.
Wait a minute.
Visible, sir.
Okay. Now whether it is visible?
Yes,
Now
sir.
visible, Ram sir.
Okay, ma'am. Thank you. Okay. Fine. So I will draw it in the board. Okay. So in this case, what we have told, I naught is equal to what? 0. I1 is equal to x bar. Okay. I2 is equal to 1 and I3 is equal to x. Is it correct? Is it correct? Okay. I am using a 4:1 multiplexer, correct? So 4 inputs I will be having. So in that we will be getting 1 output. So 4 input lines, okay, that are named as I0, I1, I2, I3. Okay. So we are having 2 select lines that we termed as S1, S0. Here in the problem we are having 3 variables. Okay. So in that I am assigning S1 is equal to Y and S0 is equal to Z. The missing variable is X. Okay. For I0 we must give the logic as 0. Okay. For I1 the input must be X bar. That means this X has to be complemented and given as an input to I1. Clear? Next, for I2, the input must be 1, the logic 1. Okay, logic 1 means you have to connect it to 5 volt. Logic 0 means it has to be connected to 0 volt. Clear? For the third input, it is X. From here, I am directly giving. Before the NOT gate, if I am taking the input, it is X only. Okay? So now, in the problem, we will be having the output as Y. Okay, in the problem, we have sigma of, what are the terms we have got? 1, 2, can you tell me? I may not see the screen, wait a minute. What about the function I have told? The function I have told is 1, 2, 6, 7. Okay, so 1, 2, 6, 7. Okay, 1, 2, 6, 7. Sigma of Y is equal to sigma of 1, 2, 6, 7. Fine. So from this minterm, எது கொடுத்தாலே எனக்கு output என்ன வரணும்? I must be getting 1. Okay. So already I have told 2 examples. 6 எடுத்தாச்சு, 7 எடுத்தாச்சு. I am going to consider this one. Okay. Or else, இதில் இல்லாத ஒரு minterm எடுத்துக்கலாம். That will be fine. Fine. Say for example, I am going to consider the minterm 3. 3 means how I can write? 0, 1, 1. Correct? 0, 1, 1. So what I have to do? For X, I must be giving 0. For Y, I must be giving 1. For Z, it is 1. 0, 1, 1. This is the input I am giving actually. Clear? See, the mux அப்படின்னு சொன்னாலும் நான் என்ன பண்றேன்? 3 வேரியபிள் எப்படி அசைன் பண்ணிருக்கேன்? X ன்னு ஒரு வேரியபிள் இருக்கு. We are having 2 more variable YZ. YZ, I am using the select line. Okay? Now, இந்த காம்பினேஷனுக்கு என்ன அவுட்புட் வரும்? நீங்க சொல்ல முடியுமா? Here we are having the combination. Select line is 1, 1. So I3, இந்த I3 என்ன இருக்குமோ அதுதான் இங்க வர முடியும். Correct? What about I3? We are having X. What is the value of X? It is 0. So what about the output we will be getting? 0. Correct? So 3 அப்படின்ற minterm கொடுத்தா எனக்கு என்ன வருது? Output 0 வருது because in the given function we don't have the minterm 3. Correct? Is it clear now? Is it clear now? Or still you are having doubt? Kindly type it in the chat so that I can understand. I can know. Is it clear or not? Show for 6. Okay, I will show for 6. Okay, I will show for 6. 6 means what? Okay, 6 means what? 6 means how we can write? 1, 1, 0, correct? So x is equal to 1, okay, y is equal to 1 and z is equal to 0. Clear? So here the select line 1, 0 means what? This will be getting as the output. What about I2? We are having 1. So straight away we will be getting 1 in my output. Is it clear now? Is it clear now? Yes. Okay. See, if any other doubt, you can kindly ask me. Okay.
Sir,
We will
please
again
show for
present on the
7, sir.
PPT. Huh?
Sir, please show for 7 also, sir.
For 7 also you need. Okay. Fine. Wait a minute.
Yes.
Okay. For 7. Is the screen is visible for all of you? Yes?
Yes,
Yes, Ram
sir.
sir.
Okay, ma'am. Okay. Okay. So in the case of 7, we will be going to have 1, 1, 1. Correct? So x is equal to 1, y is equal to 1, z is equal to 1. Y equal to 1, z is equal to 1. That means S1, S0 is equal to 1, 1 means, so I3 output will be getting selected at the output. So in this case, x is equal to 1. So here we will be getting 1. So the output is 1. Clear? See, என்ன காம்பினேஷன் போட்டாலும் சரி, இப்போ நீங்க என்ன மின் டேர்ம்க்கு டிசைன் பண்ணீங்களோ அது மட்டும் தான் எனக்கு என்ன வரும்? 1 வரும். மிச்சதெல்லாம் 0 தான் வரும். Clear?
Sir, I2 also having 1 now, sir. It will not go over, sir.
Huh?
I2 also having 1 now, sir. It will not go over, sir.
See, you should not see for the select line. You have to apply x, y, z value.
Okay, sir. Okay, sir.
2 means you have to consider 0, 1, 1 because you are having 3 variables. You have to consider x also. Is it clear? Kana புரியலனா கேளுங்க. I will repeat it one more time. Okay, now it is clear. Srihari, புரிஞ்சுதாப்பா? Srihari?
Sir, sir.
Okay,
Sir.
okay, fine. So we will move with the next problem. Fine. So in the problem board lay solve பண்ணிடலாம். Fine. You can solve this problem also. Okay, so that you can have a clear idea. Fine. I will solve it in the board. Okay. So now I am going to solve from the board. Okay. So the problem is sum of f of a comma b comma c comma d is equal to sum of the minterms 0, 1, 5, 6, 8, 10, 12, 15. Okay, fine. Now you tell me using 4:1 mux. That is the problem. 4:1 mux. First thing, 4:1 mux means how many select line we must be having? How many select line we must be having? Kindly type it in the chat. I will see it. Yes, 2 select line. Okay. So we are having 2 select lines. 2 select line. So how we have to assign the value? For C, I am going to assign the select line S1. For D, I am going to assign the select line S0. Is it clear up to this? Is it clear up to this? Yes? Yes or no?
Sir,
Yes,
can
sir.
we select A and B, sir? As S1
We
and
can
S.
select like that also S1, but we will use certain procedure, so we may clearly do this. In the implementation table, நமக்கு clear புரியணும் அப்படினா, you can also do with A and B, fine. But நம்ம காமனா ஒரு விஷயத்தை follow பண்ணோம்னா, for any problem, it is a universal solution. For that we are doing this method.
Okay, sir.
Okay, fine. Now,
Okay, sir.
What are the missing variables? Select line C, D. நம்ம கொடுத்தாச்சுனா missing variable என்னது? A, B. Correct? So A, B are the missing thing. Fine. Now, what are the inputs for your multiplexer? I0, I1, I2, I3. Fine. What are the missing variable I am having? A, B. As I am having two variables A, B, what I am going to do is A bar, B bar. That means 0, 0. Okay. So here we have C bar, D bar, C bar, D, C, D bar, C, D. Okay. Now, A bar, B, 0, 1. A, B bar, 1, 0, A, B, 1, 1. Okay, now we have to write the terms 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So up to this, clear for all of you? How to draw this implementation table? The input of the multiplexer I have written, missing variable A, B, the 4 combinations. As we are having 2 variables, 4 combinations we can have 0, 0, 0, 1, 1, 0, 1, 1. Please remember one thing, it is not K-map table. இங்க வந்து 1, 1, 1, 0 அப்படிலாம் யோசிக்க கூடாது. Normal numbering we are using. Clear? Now we have to circle. என்னென்ன மின் டேர்ம்லாம் இருக்கு? 0, 1, 5, 6, 8, okay, 10, then 12, okay, finally we are having 15. Is it clear up to this? Is it clear up to this? Yes? Yes or no?
Yes, sir.
Okay, fine. Now, இங்க என்னென்ன டேர்ம்ஸ்லாம் வந்திருக்குன்னு பார்க்கலாம். So I0 is equal to, I will write out the terms. என்னென்ன டேர்ம்லாம் அந்த காலம்ல வந்துருக்கு பாருங்க. A bar, B bar, one term. அடுத்து A, B bar, அடுத்து AB. கரெக்டா? So A bar, B bar plus A, B bar plus AB. Correct? என்னென்ன டேர்ம்லாம் வந்திருக்கோ அதெல்லாம் எடுத்து R ஆபரேஷன்ல எழுதிக்கிறோம். Fine? So from this we can take B bar as common. Correcta? B bar common எடுத்தீங்கன்னா என்ன வரும்? A bar plus A வரும். A bar plus A plus AB you will be getting. Okay? So from this here you will be getting B bar plus AB. How we can write this term further? B bar plus AB. Further எப்படி எழுதலாம்? Distributive theorem apply பண்ணீங்கன்னா B bar plus A dot B bar plus B. Finally, we will be getting the expression as A plus B bar. I0. Is it clear for all of you up to this? Is it clear for all of you up to this? Yes or no? Yes? Okay. See, ma'am typed one reason why we are choosing the select line from the LSB. Okay. If you choose it from the MSB side, you will be having some difficulty in the implementation table. Complexity irukum. That's why. Okay. So I0 is equal to A plus B bar. What about I1? Can you type it in the chat? You people try and type it in the chat. What about for I1? What about for I1? I1 is equal to what? I1 is equal to A bar B bar plus A bar B. So from this you can take A bar as common. So B bar plus B. So this becomes A bar. So I1 is equal to A bar. Is it clear? Is it clear or not? புரியுதா புரியலையாப்பா? ஏதாவது டைப் பண்ணுங்க. Yes, okay. Then next term என்ன இருக்கு பாருங்க. I2 is equal to what? I2 is equal to what? A bar B plus A B bar. Can you type it in the chat? What we can write this? What we can write for this?
XOR, sir.
Very good, super, XOR. So A XOR B. So I2 is equal to A XOR of B. The last one, I3, we are having only one circle. So the corresponding என்ன இருக்கு? AB. I3 is equal to AB. Okay? Fine. So now I am going to erase this space. இதை erase பண்ணிக்கலாமா? Kindly take a screenshot quick. So another 5 minutes இருக்கு, அதுக்குள்ள இந்த diagram மட்டும் பார்த்துரு. So I0 is equal to what? A bar plus B. Okay. Next one is A bar. Next one is A XOR B. The last one is AB. Fine. Shall I erase? Note பண்ணிட்டீங்களாப்பா? Diagram வரையலாமா? Shall we go with the diagram? Yes or no? Yes. Okay. So time ரொம்ப கம்மியா இருக்கு, diagram பார்க்கலாம். Okay, now 4:1 multiplexer சொன்னோம். So we will be having 4 inputs, I0, I1, I2, I3. Okay, 4 inputs. We must be having only one output Y. Okay, 2 select lines. So that we have named as C and D. Okay, now எனக்கு என்னென்ன டேர்ம்ல வேணும் பாருங்க. I am considering A here. இது B ன்னு எடுத்துக்கலாம். What about I0? I0 is equal to A plus B bar. Okay, I am drawing it as a straight line. See, இந்த ப்ரொசீஜர்லாம் பார்த்துக்கோங்க, so that you can easily draw any circuit. Fine. So A ல இருந்து நான் ஒரு விஷயம் எடுக்கிறேன். Then B என்ன பண்ண போறோம்? We are complementing it. Okay, so you will be getting A plus B bar. Correct? Here A is there, here B bar is there. A plus B bar. முடிஞ்சதா? Next, what about I1? It is equal to A bar. So from here, I am putting a NOT gate and I am connecting here. Fine. What about I2? I2 is equal to A and B XOR with the XOR gate I have given. What about I3? A and B. We must be performing an AND gate. That's it. So that's all about the final circuit. Remaining things you can erase it. If it is needed, you can erase, or else you just leave it. Is it clear now? Dear students, is it clear now? Yes or no? Yes. See, any problem you have given in this fashion, you can go with the steps. First, you have to go with assign the select lines for your variables from the LSB. Okay. The remaining variable you have to go with implementation table, derive the function for I0, I1, I2, I3 from the implementation table. Finally, you implement the circuit. Okay. For an example, I am considering 12. 12 means what? 1, 1, 0, 0. A, B, C, D. So A equal to 0. Okay. B equal to, sorry, A equal to 1. B equal to 1. Okay. C equal to 0. D is also equal to 0. 0, 0 means which one of the input will get selected? This I0. I0 க்கு என்ன வருது பாருங்க. இங்க வர output என்னவோ? A plus B bar. A is 1. B bar is also 1. So you will be getting 1. B bar is 0. Sorry, B bar is 0. 1 plus 0 is 1. So 1 will be my output. Fine. So for this I am getting 1. You can check it. Fine. Fine. Okay. Note down this problem also. In the next class, you provide the answer for this. You provide the answer for this. Implement the full adder circuit using multiplexer. Okay. You choose your appropriate multiplexer and perform the operation. Okay. So I am going to stop the recording now. Time is 12:46. Okay. One more thing. Wait for some time, students.